What's up, guys? This is Strymes and James, and our first project was number 8 in the Arduino book. It is titled Digital Hourglass, and just as the name implies, the purpose of this setup is to mimic the functions of an hourglass in a digital way. There are 6 LEDs that light up one by one as a certain amount of time passes by, and for the purposes of actually timing an hour, we had one LED bulb turn on every 10 minutes.
Our project 8 hardware consisted of 6 LED bulbs indicated here, 6 220 ohm resistors indicated here, one 10K ohm resistor indicated here, a tilt switch, which is a little black thing that doesn't work, and some miscellaneous wiring. We expect most of you know what LED bulbs are and how they work. They emit light when current is flowing through them. Each of the 220 ohm resistors, which are indicated right after these LED bulbs, restrict the current flow through the LED bulb so they don't burn out. The 10K ohm resistor here restricts the current flow to switch 8. We're not exactly sure the use for this resistor, knowing that switch pin 8 is just to receive voltage or not, but we'll get into that more in software.
So moving on to software, the first line of code here declares a main constant switch pin and sets it equal to pin number 8 on the chip. And the next 5 lines basically just declare variables and give them all initial states. This first variable here is a variable to hold the time. The next one is reading the current state of the switch, which, as James stated earlier, didn't work too well for us throughout this project. So the next line, previous switch state, is just basically remembering what this value used to be, which will come into play later on in the code. So LEDs first set equal to pin 2, and the variable interval is a variable describing the interval between events, and it's in milliseconds, so 600,000 milliseconds is 10 minutes. Alright, so this line, a few lines of the code, sets the pins from 2 to 7 to be output, and the variable switch pin, which is set to 8 at the top here, set that equal to input. So I'll be reading input from pin 8 and then putting output to pins 2 through 7, depending on what the input is. So the for loop here sets current time equal to the amount of time that the Arduino board has been running by using this function. Then this if statement, in a nutshell, states that if current time is 10 minutes greater than previous time, that output to the pin LED is turned on, and the value for that pin is up by 1. So it starts at 2, and then after it's gone through the loop 1 time, pin will be 3, and once 10 minutes, current time is then again 10 minutes greater than previous time, then pin 3 will also get voltage, and so on until LED pin equals 7, and then you exit the for loop. So then the rest of the coding basically just reassigns values to the initially stated variables that basically if any change at the input at pin 8 is seen, then the whole system resets and the timer restarts.
Alright, so these are our special devices. We had the 7 resistors that we talked about earlier, the 6 LED bulbs that we talked about earlier, and this black little square that's actually a tilt switch. We couldn't get it to work because the prongs would not make connection to our breadboard, but in theory, while the switch is upright, a ball is touching the 2 prongs, completing a circuit. If the switch is turned upside down, the ball is not touching the connector, so it does not complete the circuit. These set of pictures is our system working. And you can see in picture 1 that 10 minutes have elapsed and we have 1 LED bulb on. Second picture, you have 20 minutes elapsing making a second LED bulb come on. Then the third picture 30 minutes, the last picture 50 minutes. As you can see, we did not incorporate our tilt switch. This is due to the prongs not reaching the contacts in the breadboard. Instead, we have a little jumper wire giving power straight to switch 8. And if we removed this jumper wire, it would have the same effect as if we tilted the tilt switch, which would cause an incomplete circuit.
Alright, so one of our extensions asked us basically once all 6 lights are lit up, they just stay lit up until the system is reset by either removing or reinserting the wire. It said basically once they're all on, how do we get the attention of somebody? That an hour had elapsed. So we had the idea of basically having all lights flash on and off continuously, but we struggled to get the coding for that right. We understood the logic of having all the pins 2 through 7 have power and then delay by a second or so, and then cut power and then delay again by a second, all in a loop statement, but we just couldn't get the coding right for it.
Our second Arduino project was number 13. It is called Touchy Feely. The objective is to turn an LED bulb on when we touch a piece of conductor on the circuit. The Arduino constantly measures the capacitance of the circuit. When the conductor is touched, the capacitance is increased due to adding your body's capacitance. The Arduino senses this change, thus lighting the bulb. FYI, the capacitance is a measure of how much electrical charge something can store.
So moving on to the hardware of Touchy Feely, we have one LED, and we had one 220 ohm resistor, and then one mega ohm resistor, and we were supposed to have a conductor or piece of metal foil that had a small capacitance, but we ended up not using it for our test runs, and we got it to work fairly well since we figured that the little piece of wire that was supposed to lead to the metal foil had a small capacitance as well.
Alright, moving on to our coding or software for our Arduino project. Line 1 of the code calls upon a capacitor sensor library that we had to download for this project in particular. Line 2 calls upon the capacitor sensor function to measure the capacitance between output on 4 pin and the input on pin 2. So it would be this loop from this orange wire to this red wire. Line 3 of code is setting an integer to the name threshold and setting that to the threshold of 1000, which is the threshold of capacitance before the LED bulb comes on.
So line 4 of the code is basically just telling the Arduino chip that it will be sending output to pin 12 since the LED will be connected to that pin.
Alright, line 6 of code, give me a second, opens a serial connection at 9600 BPS. We'll use this to see our values the sensor is reading. Line 7 of code is identifying pin 12 to be an output. Line 9, we're starting our never-ending loop function. And line 10 would be our first segment of code within that loop, which sets a variable named sensor value to the measured capacitance within our Arduino system. The 30 in the capacitor sensor command is telling the system to take 30 measurements of capacitance and average it to obtain a more accurate capacitance measurement. The code in line 11 is just telling the system to print the measured capacitance value out for us. The code through lines 12 through 18 is telling the system to send power through pin 12 to the LED bulb if the measured capacitance is higher than the threshold that we assigned earlier in the code. And if the system measures anything below the threshold, it is told to not send signal through pin 12. And then line 18 delays the whole loop process by 10 milliseconds.
So as mentioned in the coding part of the screencast, we had to download a library from this URL and download it to the computer, then unzip it, and then create a folder in our documents of the Arduino folder. Create a new directory named libraries, and then place the unzipped file in that folder. And then in order to basically make sure that we did everything correctly, we had to reopen Arduino software and go to File, Examples, open the what was now the new capacitive sensor library, and open a project, and then compile it directly after. And if it was able to compile, it was done correctly, and if not, it was not. And the first time I tried this, it actually did not compile correctly, and that was because it wasn't in the right library folder, like in the exact right spot. So I kind of just moved things around and tried it again, and ended up working. So yeah. Unfortunately, we were not able to have the video that we took in class showing our setup working. But every time somebody would touch the end of this wire, the LED would turn on, and once you let go, it would turn off. I had taken a video of this, and there were actually some students in class who saw it working, but there was also another video that I accidentally took, and I meant to delete that one afterwards, but I deleted the wrong one, and so we don't have any good footage. In order to get it working, though, as seen in the code earlier, the threshold was set to 1,000. What we had to do was change that threshold to somewhere around 50. So let's see, this threshold right here is about 1,000. We had to change that all the way down to 50, or even around 75 or 100 maximum, in order to have it work properly. While it was at 1,000 though, somebody would have to be holding that, and then somebody else would also have to touch any kind of metal somewhere else in the circuit. They could touch the metal of this resistor, they could touch this LED, but we couldn't like grab hands and basically combine ourselves, which was weird. We didn't really understand that because we thought that it would make the capacitance the same size as touching something over here. So that was really confusing. We couldn't really figure out why it necessarily had to go through the rest of the board, or why somebody else had to be touching it, but we made the best of it and just lowered the threshold, and it all worked fine.
To wrap this shenanigans up, we found these Arduino projects to be quite useful in becoming familiar with the Arduino system. We feel we'll be able to use these newly acquired skills to maybe be more independent in creating our own Arduino projects and possibly projects at home.